Good morning. Today we're going to talk about graphing radical functions. We're going to focus today on the square root of x and its transformations. The transformations are just like what we've been doing in the past. I know there's this watermark here and it's going to be kind of annoying, but I don't have a way to get rid of it right now, so we're just going to have to deal with it. You're going to want a graphing calculator just so you can kind of see some things. And we're also going to get 2 pieces of graph paper from the front table. Okay, so let's talk about the square root of x. We're going to pick some values for x. Okay, so we'll just start with 0. What's the square root of 0? It's 0. Okay, pick another number. How about 1? What's the square root of 1? It's 1. How about if we put 2? What's the square root of 2? Well, the square root of 2 is about 1.41 if you use your graphing calculator there. Okay? We can pick 3 and put the square root of 3 in as well, but let's pick numbers that are nice and neat and give us things that we can work with very easily. So the next perfect square we might know is 4. What's the square root of 4? It's 2. 5, 6, 7, and 8 aren't perfect squares, so we can pick those and get decimal approximations, but that's not really going to help us either. So the next one we're going to pick is 9, and the square root of 9 is 3. Now we're going to look at the graph. Before we did that actually, how come I didn't put -1 in here? Right, because when we take the square root of a negative number, we can't do that. It does not exist. So we can't do the square root of a negative. So let's plot these points. We've got 0, 0, 1, 1, 2 about 1.41, 4, 2, and 9, 3. And so we have a curve that starts here and kind of arcs up. It's going to continually get higher, because when we get out here to 16, it's going to be 4. When we get out here to 25, it's going to be at 5, and it's going to continue. Okay, so now before we look at anything else, we need to talk about what the domain and the range for this function are. Okay, the domain. What are my x values? Well, what do we say x cannot be? Right, x cannot be negative. So our domain is all positive real numbers. Okay. How about our range? When we take the square root, do we ever get any negative numbers? No. We're only talking about this top arc. So our range is also all positive real numbers. Okay? Now we need to keep that in mind when we talk about some other ones. All right, talk to your side partner in just a minute. What do you think this plus 5 is going to do? Right. So we're going to look at this plus 5, and our prediction should be that it's going to move it up 5. Well, let's try. Let's plug in some values and see what happens. So if we plug in 0 for x, we get the square root of 0, which is 0, plus 5 is 5. Okay. If we plug in 1, we get the square root of 1, which is 1, plus 5, which is 6. Now, we said we're not going to pick 2 and we're not going to pick 3 because those aren't perfect squares. So our next one is to pick 4. The square root of 4 is 2. 2 plus 5 is 7. Okay. So this was 0 plus 5. This was 1 plus 5. Okay. And we can pick number 9, because that's also a perfect square. The square root of 9 is 3. 3 plus 5 is 8. So now we're going to go down here and we're going to plot those. So we had 0, 5. Notice, where does our graph start? It starts at positive 5. Normally it started down here, but we moved it up 5. We had the point 1, 6, the point 4, 7, and the point 9, 8. So it moved it up 5. So what is our domain now? Our domain is still all positive real numbers. Our range, however, now is y is greater than or equal to 5, because it's the lowest value of y value we can have. Okay? Now, what do you think will happen when that x minus 4 gets under the radical? So instead of being outside the radical, it's now under the radical. And make sure you're graphing these with me. Okay? So what happens if we put a 0 in here? 0 minus 4, that's going to be a negative number. Can we take the square root of a negative number? No. What's the smallest number we could put in here? We can put a 4 in. So we have the square root of 4 minus 4, which is the square root of 0, which is 0. I could put a 5 in. That gives me the square root of 5 minus 4. That equals the square root of 1, which is 1. I could put a 6 in. That gives me the square root of 6 minus 4. That equals the square root of 2. We can do a decimal approximation, but that's not probably our best choice. We've got 1.41. If I put a 7 in, that gives me a 3, not a perfect square. But if I put an 8 in, that gives me the square root of 8 minus 4, which is the square root of 4, which is 2. So let's look at graphing this. So we have the point 4, 0. Notice what happens to our curve here. Here's the point 4, 0. Normally we started here, and now we've moved this direction. Then we have the point 5, 1. We can graph 6, but that's a decimal. The next value we got was 8, and that was a 2. Again, we have this arc. So what did our graph do? It moved to the right 4. But look what our curve said. X minus the square root of x minus 4. So remember, under the radical, it's just like being inside the parentheses. It moves it left or right, but our sign is opposite. What's our domain then? Well, is it all positive x's? No, our x's start at 4. So our domain is x is greater than or equal to 4. What's our range? Well, if we look down at our graph, our y start at 0 and get bigger. So that one would be all positive reals. Or we could say that y is greater than or equal to 0. All right, talk to your side partner. What do you think is going to happen when we put the two things together? Right. This is going to move it left or right. This is going to move it up or down. Well, what's our prediction? Okay, it's going to move it not up. It's going to move it down 2. That's this number. But under the radical does the opposite, so it's going to move it to the right 3. I will show you more when I'm back about how to put this into your graphing calculator. But for now, let's put some numbers in. Okay? So for example, what is the smallest number I could put in here? 3 is going to be the smallest, because if I put anything smaller than 3, then it's going to be a negative number. But 3 minus 3, So I have 3 minus 3 minus 2. 3 minus 3 is 0. The square root of 0 is 0. 0 minus 2 is negative 2. If I put a 4 in, I get the square root of 4 minus 3 minus 2. Notice this is 4 minus 3 is what's under the radical. This gives me the square root of 1 minus 2, but the square root of 1 is 1. Minus 2 is negative 1. I'm going to give myself a little bit more room here. Okay. Now, if I put a 5 in, 5 minus 3, that's 2. Square root of 2 is not a nice, neat number, so we're going to skip over that. If I put a 6 in, that gives me a 3. So the next number I probably want to try to put in is a 7, because 7 minus 3 is 4, which is a perfect square. So I get the square root of 7 minus 3, and then minus 2 outside. 7 minus 3 is 4. So I have the square root of 4 minus 2. But the square root of 4 is 2. 2 minus 2 is 0. If I put an 8 in, I get 5. If I put a 6 in, I get, if I put a 9 in, I get 6. If I put a 10 in, I get 7. I'm going to be off the graph here, but can we make enough of a prediction about what's going on? So let's try to graph these. So we had 3, negative 2. So we went over 3 and down 2. Then we had 4, negative 1. So 4, negative 1. Then we had 7, oops, and 2 minus 2 we forgot to put up here, is 0. So 7, 0. We have a curve that starts here and arcs up. Okay, so what is our domain? Well, where do our x's start? Can we have anything over in here? No, so our x's start at 3 and get bigger. So x is greater than or equal to 3. What does our range start? Well, our y's start at negative 2 and go up. Okay. Now, what do you think is going to happen if we multiply our result by 2? Okay, well, let's try it. So let's put a 0 in. So I have 2 times the square root of 0. But the square root of 0 is 0. So 2 times 0 is 0. If I put a 1 in, I have 2 times the square root of 1. But the square root of 1 is 1, so 2 times 1 is 2. 2 isn't a nice number. Okay, 4 is the next number we're going to try. So if I take 2 times the square root of 4, the square root of 4 is 2. 2 times 2 is 4. Let's try 9. That's the next perfect square. 2 times the square root of 9. Square root of 9 is 3. So 2 times 3 is 6. So let's plot those. So we have 0, 0. We had 1, 2. We had 4, 4. And we had 9, 6. What do you notice about that one? Right, if we compare that to this first one here, it gets a lot steeper. It was here. That graph was 2 times the square root of x. It was here, 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 and here. We call that a vertical stretch. So when we multiply here, we take and we get it bigger. Does that impact our domain or our range? Well, let's think about that. What values of x can we put in? We can start at 0 and get bigger. So our x is greater than or equal to 0, or all positive roots. Our range is the same way. Y is greater than or equal to 0. So that doesn't impact it. What do you think happens if you multiply by a number less than 1? Okay. So let's try this. So I have 1/4 times the square root of 0, but that's just 0. If I put a 1 in, 1/4 times the square root of 1, 1/4 times 1 is 1/4. 4 is my next perfect square. I have 1/4 times the square root of 4, but the square root of 4 is 2. 1/4 times 2 would be 2/4, or 1/2. Put a 9 in. 1/4 times the square root of 9 is 3 times 1/4, which is 3/4. So what do you notice is happening here? Right, we had 0, 0. We had 1, 1/4. We had 4, 1/2. We had 9, 3/4. This curve doesn't get very big very quickly. It's what we call a compression. Our domain and our range haven't changed. It's still all positive reals, or x is greater than or equal to 0. And our range is y is greater than or equal to 0, or all positive reals. We're going to look at one last problem. What do you think will happen if we multiply that square root by a negative number in front? Well, let's try it. We have 0. So we have the negative square root of 0. But negative 0 doesn't really make sense, so it's just 0. What happens when we put 1 in? Now when you take the negative square root of 1, notice it's not the square root of negative 1, the negative's out front. Square root of 1 is 1, but we have the negative of 1, so negative 1. If I put a 4 in, I've got the negative square root of 4. That gives me negative 2. If I put a 9 in, I get negative square root of 9. That equals negative 3. So what happens when I graph those? Well, I had 0, 0, but I had 1, negative 1. I had 4, negative 2, and I had 9, negative 3. It takes that curve and it reflects it over the x-axis. Okay. What is our domain? Our x's are still greater than or equal to 0, or all real numbers. But our range now, instead of being the positive y values, is now the negative y values. So we could say the negative reals, or we could say that y is less than or equal to 0. Okay? All right. So for the next time we meet, I want you to summarize what you think happens. If we add or subtract a number under the radical, what does it do to the curve? How does it move it? If we add or subtract a number outside of the radical, how does it move it? If we multiply by a negative, which we just did, how does that change it? If we multiply by a number less than 1, how does that change it? If we multiply by a number greater than 1, how does that change it? So make sure you get this written down, and I'll give you your homework assignment here in just a minute. Okay, here's your homework assignment. On page 256 in the book, you're going to do 3 through 8 and 19 and 20. Okay, there are the problems. Here you're going to match the function with the graph, and here you're going to describe the transformation and sketch a graph of it. You should have enough graphs that you can be able to do that.